Have you ever wondered how those swirling storms that dominate our weather forecasts come to be? These meteorological phenomena, known as mid-latitude cyclones, are not just confined to the vast plains of the United States. They can also form over the Mediterranean region, exhibiting their power and influence over a wide geographical area. These cyclones, born through a process called cyclogenesis, are not to be underestimated. They are intricate and complex systems with unique structures that allow them to bring about severe weather changes and even major winter storms. Perhaps you've heard of the term extratropical cyclone, or remember the super outbreak of severe weather in 2011, or maybe the infamous 1993 superstorm rings a bell. All these events are linked to the fascinating world of mid-latitude cyclones. So let's embark on a journey into the heart of these storms. Today, we will unravel the mystery of mid-latitude cyclones, their formation, their structure, and their impact on our weather. A mid-latitude cyclone's life begins with a process we call cyclogenesis. This is the birth of a storm, a fascinating and complex dance between air, heat, and moisture that eventually gives rise to the swirling tempests we know as mid-latitude cyclones. Cyclogenesis begins when differing air masses collide, creating a boundary known as a front. Picture a battleground where warm, moist air from the tropics meets the cold, dry air from the poles. This clash of air masses forms the front, which is the cradle where our cyclone will be born. Now, fronts are not static entities, they are dynamic and ever-shifting. As the warm air mass pushes against the cold one, undulations or waves begin to form along the front. These waves are the precursors to our cyclone. At this stage, the system is still in its infancy, a mere ripple on the meteorological radar. As the wave grows, the warm air begins to rise above the colder air, creating an area of low pressure at the surface. This low pressure area is the heart of our budding cyclone. The air within this area starts to rotate due to the Coriolis effect, which is caused by the Earth's rotation. This rotation marks the true beginning of our cyclone's life. The warm air continues to rise, creating clouds and precipitation, while the cold air sinks, driving the rotation of the cyclone. The cyclone grows, feeding off the energy of the rising warm air and the sinking cold air until it reaches its full potential. It's important to note that not every wave on a front will become a cyclone. Many factors, such as the temperature difference between the air masses, the moisture content, and the speed of the air masses, play a role in determining whether a wave will grow into a full-blown cyclone or dissipate into nothingness. So, that's how a mid-latitude cyclone is born, but its journey is far from over. Once born, the cyclone continues to grow, taking on a distinct structure. In this period of growth, a mid-latitude cyclone evolves, developing a unique, identifiable structure. It all begins with the warm and cold fronts that form around the central low-pressure area. The warm front, gentle and slow-moving, advances in a broad, curved path. It pushes warmer air into the atmosphere, creating a region of rising air that forms clouds and precipitation. Conversely, the cold front, being more aggressive and fast-moving, overtakes the warm front. It drives colder, denser air under the warm air, forcing it upwards. This process, known as overrunning, can result in a line of intense showers and thunderstorms. Together, these fronts, with their different characteristics, give the cyclone its distinctive comma shape, with the head of the comma being the warm front and the tail the cold front. Now let's talk about the central low-pressure area, the very heart of a cyclone. This area is where the most intense weather activity is found. The low pressure draws in air from the surrounding areas, which rises, cools, and condenses to form clouds and precipitation. As the air continues to rise, it creates a counterclockwise rotation in the northern hemisphere and a clockwise rotation in the southern hemisphere. This is the cyclone's general motion. Another fascinating aspect of a mid-latitude cyclone structure is the warm seclusion process. This occurs when the warm core of the cyclone becomes entirely encircled by colder air. The warm seclusion can intensify the cyclone, similar to what happens in hurricanes, increasing wind speeds and precipitation. In terms of their impacts, mid-latitude cyclones can be quite significant. As they mature, they can bring about severe weather conditions. The interaction of warm and cold air can lead to heavy rain, snow, and even hail. The strong winds associated with the low-pressure system can cause extensive damage. In the winter, these cyclones can generate major snowstorms. As the cyclone matures, it can bring about severe weather conditions, even major winter storms. Mid-latitude cyclones are not just fascinating natural phenomena, they have a significant impact on our lives. These cyclones can bring about drastic weather changes ranging from torrential rains to blizzards and even severe thunderstorms. The power of these systems was demonstrated in the super outbreak of 2011, which spawned an unprecedented number of tornadoes across the United States. Similarly, the 1993 superstorm, another mid-latitude cyclone, wreaked havoc from the Gulf Coast to the northeast, proving that these storms can have far-reaching effects. An intriguing aspect of mid-latitude cyclones is the phenomenon of warm seclusion. This is when a pocket of warm air becomes isolated within the cyclone's colder environment, leading to intensification. This feature, also common in hurricanes, showcases the complexity of these storm systems. These cyclones, sometimes referred to as extratropical cyclones, are a major player in our world's weather drama. So we've journeyed from the birth to the impact of a mid-latitude cyclone. We've seen how these storm systems, born from the dance of warm and cold air, go through a process known as cyclogenesis. Forming over the US and sometimes the Mediterranean region, these cyclones are more than meets the eye. Their structure, a complex interplay of fronts and air masses, makes them a fascinating subject of study. We traced their general motions and explored how these systems bring severe weather and major winter storms. We delved into the intriguing topic of warm seclusion within these cyclones and even compared them to their tropical cousins, hurricanes. We also uncovered the term extratropical cyclone and remembered the super outbreak of severe weather in 2011 and the 1993 superstorm. All these elements combined make mid-latitude cyclones a fascinating spectacle of nature's power. Next time you see a swirling storm on your weather forecast, you'll know the journey it's been on. Stay curious, stay informed.